Hi, me again. So we discussed that as well as just putting content on LinkedIn, we would do some videos, and we were going to try and get some customer feedback. But as well as getting customer feedback, what we're also going to do is try and bring in some of our partners that we work with. So today's video is with one of the key partners that we have in our business, which is Faraday Predictive, and we've got Geoff Walker on from Faraday, who can tell you a bit more about his business, where they came from, and what it is they do. And the purpose of these was, it's okay sharing content, but sometimes it's good to actually see and speak to the people that actually run these businesses. So we wanted to try and, obviously we trust these guys, so we've been doing a lot of work with them, and probably now for the last 18 months, and we've invested in the technology ourselves, and we've now got quite a few online systems that are out there in the market. So if we trust them, then what we wanted to do is obviously give them a chance to put their business on our LinkedIn page and get a chance to actually tell us a bit about it. So I'm just going to put it over to you, Geoff, and the floor is yours, and just go and tell everybody a wee bit more about you.
Well, thanks very much for that introduction, Jamie. As Jamie says, my name's Geoff Walker. I'm Operations Director here at Faraday Predictive. What does Faraday Predictive do? Well, the clue's in the name. The predictive bit's a good clue. We're all about predictive maintenance. And the Faraday bit is a good clue. What we do is associated with electrical things. What we actually sell are condition monitoring and energy monitoring and energy optimization systems for rotating machines, where the only measurements we take are voltage and current being drawn by the motor or being put out by the generator, if that's what we're looking at. And from doing some clever automated mathematical analysis of the relationship between voltage and current and how that changes, we're able to identify an astonishing amount and diagnose an astonishing amount about what's going on in the entire machine. So the motor and the transmission and the driven equipment, and to some extent the process that's being driven by the machine. And we are able to detect electrical and mechanical and operational phenomena from that. So our system automatically diagnoses the particular fault. It gives overall warnings of the present condition of the machine. It gives predicted condition 1 month from now and 3 months from now, and not just for the overall condition of the machine, but also for each of the individual phenomena that it's detecting. So it's a very comprehensive system. So first thing is, how can just measuring voltage and current drawn by a motor tell you anything about the machine and the mechanical behavior and so on? Well, the answer is that we're looking for subtle variations in the current drawn by the motor relative to the voltage. Most people are familiar with the idea that the amount of current that a motor draws is affected by the load on the motor. So if I've got a motor shaft here, if I put more load on the motor, it'll draw more current. If I put less load on the motor, it'll draw less current. So if I've got a varying load on the motor, I'll get a varying current. The current will go up and down exactly the same time the load's going up and down. And effectively, what we're looking at are very small torsional variations in the behavior of the machine. In fact, what we're looking at, effectively, we turn the motor into a torsional vibration sensor. So what we do has many similarities to conventional vibration monitoring, except where conventional vibration monitoring is looking at a radial signal or possibly an axial signal, if that's what you're looking for. We're looking at fundamentally a torsional signal. And many of the same phenomena that you can identify with conventional vibration monitoring also shows up in the torsional domain. The two are not directly comparable because some phenomena show up more strongly in the torsional domain. Some things show up more strongly in the radial domain. So unbalance gives a very strong radial signal. Not so much if you're the motor, you don't see such a strong signal, but other things like rubbing, belt drives, things like flow turbulence inside pumps show up very strongly in the torsional domain. So we have a comprehensive system and is applicable for any size of machine. Fundamentally 3-phase AC, doesn't matter if it's fixed speed or variable speed, driven by inverter. Our system is designed from the ground up to cover it. Where did this come from? Well, I didn't say in my introduction, I'm a mechanical engineer by background, even though what we do is all about measuring electrical stuff. And I started my career in the chemical industry, making some very nasty, toxic, flammable, corrosive, nasty chemicals. And an experience early on in my career where we used measurement of current drawn by a motor to identify actually what was going on with our process, resulted unexpectedly in us detecting some internal damage to one of our machines. So that was a long time ago, and that sort of lived with me ever since. And we have been working with this sort of technology for the last 10 or 15 years in total, although we only set Faraday Predictive up in 2017. So on the 1st of June this year, we had our 5th anniversary. What do we actually sell? I say we sell predictive condition monitoring predictive systems, and they're either available in permanently installed form, things like this that just mounts on a bit of DIN rail inside your motor starter. It measures the current using small split core current transformers like this. Often, if you've got a big motor, you'll have a motor protection system with a 1 amp or 5 amp signal going into the motor protection system, and so we measure on that secondary. We can use full-size current transformers if necessary, things like this, if there aren't already large CTs present. We also sell portable kits. The portable kit comes in a convenient carry case about this sort of size. This is one we take out to site. I think probably is one that's Jamie's had in his possession at some point in the past. And with those, the whole thing is set up with all of the cables and connections you need. So spring clamp CTs for measuring low current things, the same large split core CTs for larger currents. We can pick up the voltages by a number of means, either conventional Dolphin clips, or these days there are fewer things inside switchgear to be able to connect onto. So we use little probes like this, little magnetic devices that just go into the little screw terminals and they fix in there. Occasionally you can't find any of those either, and we use things like these little brain pullers, little grabbers for finding somewhere to pick up signals from. So the fundamentals are, whether it's portable or permanently installed, the technology is the same, and the results from both systems can be presented on exactly the same screen. You can do direct comparisons between machines that have been monitored using either of the two techniques. What's the output? What's the benefit you get? Well, the output is an overall alarm status in terms of red, amber or green of the machine, its current behavior, a red, amber or green for the overall machine 1 month in future, and ditto for 3 months in the future. For any faults that are detected, the system also display the magnitude of the signal, give it a color code, and provide information on what the nature of the fault is, why the system's detected it, what the cause, what the effect is, and recommended corrective action. We really want this to be as transparent as possible. Some of these kind of condition monitoring technologies look like a bit of a black box, and it's easy to think they're all smoke and mirrors. We're very keen to make sure that everything is completely visible, because we take the view that the more you can trust something, the more you know about something, the more you understand it, the more you can trust what it's telling you. Where are we? Where we're trying to go at the moment? Well, we're working with people like Jamie. Jamie's doing a great job of introducing this technology to people we otherwise wouldn't have come into contact with, and doing a great job. We're also looking to be able to deploy this same sort of technology in support of original equipment manufactured by others, things like motor starters, where everyone driving electric motor has to have a motor starter. So, and these days, those kind of devices are getting all sorts of additional processing capabilities built in. So we have the potential that by loading our algorithms into those things, we can provide end users with exactly the same experience with no additional hardware. In terms of partnering with Ailsa, I think we've had a very successful time together. We've worked very closely. Jamie and his team have been very good at getting to grips with the technology. Inevitably, there's a lot of backwards and forwards, sort of understanding exactly what the requirements of one situation are, doing some detailed interpretations. I didn't say, although the system will give you automated outputs, which work very well for black and white situations. Probably 80% of things that occur where the system will tell you what the fault is and what you should do about it and what the time is likely to be before it needs to be done. But the world's not always black and white. Sometimes it's shades of grey, and in those situations we're still in a world where a skilled and experienced human eyeball can tell you more than the automated algorithms can. And so there have been situations that Jamie's been looking at, and we've sort of worked with him to analyse the data in depth. Yeah, we're looking forward to a happy, successful continuing future for Ailsa and ourselves, and for you, Ailsa's prospective clients.
Yeah, well, I would like to come in there, Geoff. I think for us, probably at least the first 10 applications that we looked at, they were all complete oddballs. So they're all things, shaker systems, obviously wind turbine generators. It was all things that the standard type of condition monitoring that was there wasn't giving you everything that they needed. So we had a very quick learning process for us all, I think, and it was great that we just worked together and went, right, this is a wee bit different, this application. How do we approach it? And we've managed to get through all of them and come out with a good outcome for both us and the client. So I think that it's been a very, very good learning curve for us. And there's been a lot of people that have had so many good things to say about the technology and how it's actually been applied, because, as I say, there's something we've had at least 3 customers that have said, oh, we can't do any condition monitoring on that, and the MBVI was a solution. So it's been great in that front. The other thing that I would say that we see as the big benefits in the product is the ability. So if you've got more than one machine that's identical, so a lot of time you get 4 compressors in a train, you maybe get 4 or 5 pumps that are similar or the same. Being able to put all that information and easily overlap it all against each other, and you can quickly get to the bottom of, right, so pump 4 is got a difference between the other 3. Let's investigate. And the same way that the trending, whether you're doing it ad hoc using the P100 or whether you're doing it online, the ability to trend and how easy it is to overlap those trends, I think it is a great feature. So it's great at picking up the problems or the potential problems. It's great at helping analyse the data, but the ability to use that data for me is one of the key strengths of the product that you've got, because it's made our life so much easier, and we know that it's made our clients' life so much easier. Thus the reason why they're getting more and more kind of returning visits using the P100, and why more and more people are looking at the online system, because it's the ease of use of the data. You said there about transparency and being able to people to understand it, and I think that's true as well. So yeah, we've been really, really happy with the product, and we've been really happy with the service that you guys have given us, because we've probably been a bit of a pain in the backside, because everything we throw at you is a bit oddball and out there, but that's unfortunately where we come into the mix sometimes.
Yeah, there were two key things we should mention that we haven't covered so far. Why would you use this rather than conventional vibration monitoring? As Jamie says, some oddball type things like shakers or what have you, but inaccessible equipment is a really key one, because of all our measurements are made just on the electrical voltage and current. Those measurements are taken in the switchgear, not out by the machine. So you can have a machine in the most awkward to get at place. It might be roof mounted fan, or a submersible pump, or a borehole pump, or a fan mounted inside ductwork that you can't get to and go and take routine vibration readings. It really doesn't make any difference from this technology where the machine itself is, because the switch room is always going to be accessible. And that also means, in terms of aggressive environments, we don't need to worry about wet, cold, corrosive, radioactive, flammable environments, because the switchgear is almost always a clean, dry, safe place. So that's one advantage. Why would you use this instead of vibration monitoring? Well, for stuff that you can't easily get at. The second thing we haven't touched on is, because we're measuring voltage and current, and our system automatically works out what's the phase angle and lots of other electrical parameters as well, we can't help knowing what the power is that's being consumed by the machine. So we can quantify the power being consumed, the real power and the reactive power. The real power multiplied by the cost of your electricity tells you how much it's costing you to run that machine. And whilst that may not sound like rocket science, it's astonishing when you see those numbers laid out in front of you to suddenly realize how much each machine is costing you. And over and above that, because each fault takes a little bit more energy to turn, if I've got a knackered rolling element bearing, it takes a little bit, I can feel the torques going up and down several times per rev as I'm rotating this. Because the torque's going up from time to time, it takes more energy to turn the shaft than it would if there was no fault. And almost all faults result in additional energy consumption. We quantify that and we give you an estimate of how much it's costing you to drive each fault and how much you could save if you were to correct that fault. So even if your machine's not predicted to fail within the next 3 months, it might well be worth your while going out and doing some precision maintenance, like some precision balancing, precision alignment, precision belt tensioning, in order to reduce the amount of energy being wasted. So yeah, it's another whole angle that you don't easily get with vibration monitoring.
Yeah, I can give you an example of that, because obviously when we looked at the shaker motors, what we did is the client that we were talking to, they didn't have a fixed procedure and actual locations for the weights. So what we didn't know is how accurate or how efficiently those motors were running. So were the weights in the right place, or were they just put there because it got the product through? So you could use the system to then go and adjust the weight slightly to get the optimal performance of the motor, but at the same time get the product down. So that could was saving them, I can't remember the figures, but it was saving them quite a lot of wasted energy, because they get that process more efficient. And we've looked at, you've seen some of the figures of some of the motors that we've done. We've seen motors that are wasting thousands and thousands and thousands of pounds worth of energy each year, and that's just because of, as you say, one of them was just down to they had a looseness. I think it was a foundation looseness. I think it was a soft foot or something like that. And the other one was because of a bearing. But yeah, it's a fantastic system for that. That's one of the key things that we speak to people about, as everyone's trying to get towards net zero. Being able to run your plant as efficiently as possible and your process as efficiently as possible makes a huge difference. Well, I think motors, electric motors, make up, I don't know the figures offhand, I really should know them, but a huge amount of the industrial electrical consumption. And if you can save a small percentage of that, then you're making a big difference. Yeah, we've got, I think, 3 or 4 plants at the moment, and that's one of the reasons why they want us to use MBVI, so as we can help them try and understand what the wasted energy is within their processes and what we can do to help. So no, thanks. I think I don't know, that's been a fair amount of time that we've been on, so hopefully people aren't getting too bored of watching this. But we can sit here and chat all day, Geoff. I don't know, is there anything else you'd like to talk about before we head off? Because I think we'll probably need to cut this short at some point soon.
Just to say, if you've got any queries, by all means, talk to Jamie. He's a very approachable chap. If you've got any other queries, by all means, feel free to contact us. Our website's available. And yeah, we look forward to talking to you and continuing to work with Ailsa.
One thing I'll say though is follow the Faraday Predictive page on LinkedIn. So obviously you're following our page if you're watching this, but follow the Faraday Predictive page. Keep in touch with the guys. As I say, we're not precious about that. Go and follow those guys as well. They might be putting things, Geoff and the team might be putting things up that we're not on top of. So just follow us both. Perfect.
Excellent.